So continuing with where we had left off, we had launched into section 4.4, and we're talking about atomic number and a mass number. Atomic number identifies an element. It's that number on the periodic table that you see right above the symbol of the element. So element 1, for example, is hydrogen, and so on. So no other element has that number. It's just hydrogen, all right? And that's the number of protons. The number of protons equals a number of electrons. So there's a typo here. It's not N. It should be E, a negative. And in a neutral atom, the number of positives must equal the number of negatives. Mass number is the number of protons plus the number of neutrons. If you know the mass number and you know the number of protons, you subtract one from the other and you get the number of neutrons. So an isotope symbol you will see, or the symbol of an element rather, you will see where on the periodic table you have the symbol of the element, and then right on top of it you have a number associated with it. This is a whole number because you are obtaining this number by counting. So for example, hydrogen has got an atomic number of 1. That means that in an element of hydrogen, every hydrogen atom in it will have 1 proton. So atomic number of copper is 29, therefore every copper atom has 29 protons. So here in this picture you see atoms of carbon and lithium. Lithium has 3 protons and 3 electrons, because remember the number of positives must balance the number of negatives, and it has 4 neutrons, so it has a mass number of 7. Carbon, on the other hand, has 6 electrons and 6 protons and then 6 neutrons, so it has a mass of 12. Okay. Now, nowhere in the periodic table will you see the mass number listed. Mass number again is obtained by counting. You're simply counting up the number of neutrons and electrons and adding them up. Mass number is a whole number. What you see on the periodic table listed right below the symbol of the element is a fractional number, and that's called as atomic mass. So the net charge in a neutral atom is 0, therefore the number of protons must equal the number of electrons. As you can see here, for aluminum, 13 positives and 13 negatives will give you a net charge of 0. Okay, so you're asked to fill up this table using the periodic table. So nitrogen, atomic number 7, zinc, atomic number 30, and then sulfur, atomic number 16. So the number of protons and number of electrons will equal that atomic number. So the numbers here will be all the same. Okay, so it'll be 7, 7, 30, 30, and then 16, 16. So the mass number again is a whole number. You're simply counting up the number of protons and number of neutrons and adding them up. Again, does not appear in the periodic table. All right, so how do you obtain the mass number? Okay, what you do is you count up the number of protons and neutrons, and that gives you the corresponding mass number. All right, 7 plus 7, 14. 8 plus 8, 16, and so on. And the other thing you will notice is that the numbers here in this particular column under atomic number match up with the numbers under this column for number of protons, and it's the exact same number for number of neutrons, whereas the numbers for this column is again 14 minus 7 gives you 7, 16 minus 8 gives you 8. All right, so mass number minus the number of protons gives you the number of neutrons. Okay. All right, so an atom of lead has a mass number of 207. How many protons are in the nucleus? It would be 82. Lead is element number 82. How many neutrons are in the nucleus? That would be 207 minus 82, so that's 125. How many electrons are in the atom? And the electrons would be the same as the proton number, and that would be 82. So here, when you write a symbol of an element this way, with the mass to the left of the symbol as a superscript and the atomic number or the number of protons to the left of the symbol as a subscript, this is called as an isotope symbol. All right, so unlike the periodic table where the atomic number was up on top and then the mass was listed below, this is kind of in reverse order. Now if you subtract 12 out of the 24, you get the number of neutrons. So here, in this particular atomic or isotope symbol, as it's called in some of the textbooks, you will see that the way you write the atomic symbol when you're writing it is, again, you have the symbol of the element, and to the left of it, the subscript is the mass number, and then the atomic number is the subscript is the atomic number, and the superscript to the left of the symbol is the mass number. All right, so here you're given the atomic symbols of oxygen, phosphorus, and zinc. So oxygen has 8 protons, and then 16 minus 8 gives you 8 neutrons, 8 electrons as well. Phosphorus has 15 protons, 15 electrons, and then 31 minus 15 gives you 16 neutrons. Zinc has 30 protons, 30 electrons. 65 minus 30 gives you 35 neutrons. Okay, so you see that this atomic number here, the numbers match up with the number of protons. Mass minus the number of protons gives you the number of neutrons. So here in this picture, you are shown isotopes. So what is an isotope? Isotope, as you can see here, they're all magnesium. The reason they're all magnesium is because of the number of protons. They're all 12, all right? So therefore, element number 12 is magnesium. However, you see that their mass numbers are different. This has 24, this is magnesium 25, and this is magnesium 26. So they're differing in the number of neutrons, all right? Magnesium 24 has 12 neutrons. Magnesium 25 has 13 neutrons, and then magnesium 26 has 14 neutrons. The other thing you see here is a percentage associated with each of these isotopes. Now, this indicates how abundant they are in nature, all right? So magnesium 24 is the most abundant because it has the largest percentage abundance, which is 78.70 as indicated here, all right? So these isotopes occur to a lesser extent, magnesium 25 and 26. The most abundant isotope is magnesium 24. Now, when you look at the listed atomic mass for magnesium in the periodic table, it reflects the most abundant isotope of magnesium. All right, so here you have those 3 different isotopes for magnesium, and then the actual mass of the isotopes, and then you have the number of neutrons, and we've talked about that already, and then the percentage abundance is listed right below the masses. Now, how do you obtain that atomic mass of 24.31? And what you do is take the percentage mass. So if it was a straight average, you would have simply added these 3 masses and divided by 3. But this is a weighted average. The atomic mass that is obtained, that is listed in the periodic table, is obtained by performing a weighted average. And the weighted average differs in a straight average in the sense that you're taking the percentage of each one, and then you're multiplying it by the respective mass, and then adding up those fractional masses to get the final mass. So 78.70%, so that means you're taking the 78.70, dividing it by 100, so you move your decimal point 2 places to the left. So 0.7870 times the mass corresponding, which is 23.99, all right? And then 0.1013 times the 24.99, and then 0.1117 times 25.98. Now, those fractions that you get, you add them up together, and that gives you the 24.31, the atomic mass. So this is how the weighted average for the isotope is calculated. Here you have three isotopes of carbon, carbon 12, 13, and 14. So since they're carbon, the protons and electrons will be the exact same number, and that will be 6, all right? The neutrons will differ. Carbon 12 has 6 neutrons, carbon 13 has 7 neutrons, and carbon 14 has 8 neutrons. Write the atomic symbols for the following subatomic particles. So this is oxygen 8, and it has 8 neutrons, so mass is 16. This is chlorine, and 17 plus 20 means it is 37. The mass is 37. This is silver. 47 plus 60, 107 is the mass. Okay, which of the pairs below are isotopes of the same element? Well, they have to have the same atomic number, so B would be the answer. In which of the pairs below do both atoms have 8 neutrons? So it has to be C, because 16 minus 8 gives you 8 neutrons, and then 15 minus 7 will give you 8 neutrons. Atomic mass. So we looked at how atomic mass was calculated. You're basically taking the percentage times the corresponding mass, and then those fractions you're adding it up together, and that's how you get 35.45 for chlorine. So here is another example with magnesium, and we've already looked at it before. So basically you're taking the percentage, that number, divide by 100 times the corresponding mass, and then you get those different fractions. You add them all up together to get the final weighted average mass. So here you have the isotopes of different elements here, and if you look at the weighted average, it's going to be the closest to the most abundant isotope, which in this case is lithium-7. All right, so that's the most prevalent isotope. Again, 12 for carbon, that matches up with the carbon-12 atom. And so on. So the weighted average masses reflect the most abundant isotope for that particular element that occurs in nature. So lithium consists of two naturally occurring isotopes, lithium 6 and 7. According to the periodic table, the atomic mass of lithium is 6.941. So which is the most prevalent? It would have to be lithium 7. Gallium is an element found in lasers used in compact disc players, and in a sample you have 60.10% of gallium, atomic mass 68.926, 39.90% of gallium, atomic mass 70.925. What is the atomic mass of gallium? So you have to move the decimal point 2 places to the left. 0.6010 times 68.926, 0.3990 times 70.925, and then add up the fractions. Okay, so you get 41.42 for gallium-69 and 28.30 for gallium-71. Add it up together and you get 69.72, showing that gallium-69 is the most prevalent isotope. And make sure to answer questions on pages 113, 116, 120, and through 121. And that's the end of this section.